Alright, so in this video we're going to talk about the other labs that we did. So one of the other ones that we took was, zinc, solid zinc, or we called it zinc mossy, and we placed it in hydrochloric acid. And you guys would know that as hydrogen monochloride or hydrogen chloride. Alright, so then what happened was we got the gas to ignite when we brought a flame near it, and it barked. It made that famous bark that we talk about, which by now we should know is hydrogen gas. Okay, so hydrogen gas produces the bark, and you guys know what I mean by that. We've heard it in the lab a couple times. All right, so if we take a look at this reaction, to get hydrogen alone, zinc had to boot it out and combine with the chlorine. Okay, so we got hydrogen gas and zinc chloride. Zinc chloride is ZnCl2. Going back to basics again, zinc is a 2 positive, chlorine's a negative. It takes 2 chlorine for that 1 zinc, hence where we got ZnCl2. Right, so you cannot forget to go back and look at your charges when you write formulas. All right, so we have our two products. This is a cationic single replacement or single displacement, whatever you want to call it. Both are acceptable because the cation replaced the other cation. So zinc kicked out hydrogen and combined with chlorine. All right, so in this case, the hydrogen gas was produced, which produces the bark, and that's what we want to look for. So we've got the CO2 putting out the flame, the oxygen reigniting or making the flame bigger, and the hydrogen produces that pop or that bark. Let's take a look at balancing here. I have 1 zinc, 1 zinc, 1 hydrogen, 2. So I'm going to put a 2 there. Oops, sorry. 2, which gives me 2 chlorine, 2 chlorine. We're balanced. And we already said cationic single replacement. So make sure you're looking for those 3 things tomorrow. Now, one of the things today in class when we talked about who produced the bark, you guys were hung up on, oh, it was the hydrochloric acid. Remember, it doesn't matter what I mixed. If I ask who produced the bark, it's the hydrogen that produced the bark. So tomorrow I could take magnesium and combine it with sulfuric acid, which you guys would know as hydrogen sulfate. Okay? Bring a flame to it and it barks. When it barks, you know hydrogen gas was formed. Okay? And hydrogen is a diatom. That should be in your notes, should be on your periodic table. So we take a look. That means magnesium replaced hydrogen to get him alone. This is a single displacement. It happens to be cationic. So magnesium is a 2 positive. Sulfate's a 2 negative. Once again, just coming from your periodic table. Comes together as MgSO4. Okay, so I'll get rid of this here. All right, so we've got our products written down. Let's take a look at balancing them. 1 Mg, 1 Mg. 2 hydrogen, 2 hydrogen. 1 SO4, 1 SO4. We're done. It's a cationic single replacement, and it produced the hydrogen gas that we wanted. Okay, so when I ask what produced the hydrogen gas, it's not sulfuric acid hydrochloric, it's the hydrogen gas produced the bark. We just had to kick it out to get there. Okay, and typically the best way to do that is a single replacement, but we may have done decomp, something like that. Okay, you just are looking for the bark. All right, let's look at one of the double displacement reactions we did. We had potassium iodide and silver nitrate, and both of these guys were in solution. We mixed them together, and we get KNO3 and silver iodide. And this is the one time that everything works out 1 to 1. And quickly, positive, negative, positive, negative. So when they switch, it's a 1 to 1 ratio. Do not fall under the assumption that will always work that way, because most of the time it won't. So remember, always look up your charges and see how they're going to switch. This is a double displacement reaction, or double replacement, depending on what title you'd like to give it. And we notice that everything's balanced because it was just 1 to 1. Okay. The one other piece of this that we need to talk about is this reaction produces a precipitate, which remember means that you get that cloudiness, that solid is formed from those 2 solutions. Nitrates, okay, will always stay in solution. That means if you bring these items together and you have these 2 choices for a product, the substance that produced the precipitate is the non-nitrate substance. So in this case, the silver iodide produced the solid or the precipitate. Okay? So when you're looking at your double displacement reactions, if one of the products is nitrate, not going to be the solid or the precipitate. If you saw a solid or precipitate or you saw that it was cloudy, then it's the other substance that produces that.